Today we are going to learn about basic concepts related to the engineering graphics. Okay, in engineering graphics we basically discussed about what is drawing, and after that we discussed about engineering drawing and what is the principle behind engineering drawing. So all those things today we are going to discuss. So today, for initially we start with the what is drawing is. So drawing means it is nothing but a pictorial representation of any object or any component which gives detailed description about it. Say about its how it is look like, what is its shape, what is its size, what is its color, everything we can get to know. So drawing means it is a pictorial representation of any object or component that gives detailed description. The detailed description means, so what is the size, shape, color, texture, etc. So all these things we can able to get it from the drawing. So we all did the drawing in our childhood. We all know what is drawing means, and we have been done the drawing, right? So drawing we have done, we know that is without any dimensions or any specifications. Okay, that is drawn using a freehand sketch. But today we will be concentrating on what is engineering drawing. So engineering drawing means the drawing related to engineering discipline. Say it can be related to mechanical, or it can be related to civil, or it can be related to electronics or computer science. So drawing it, engineering drawing, it has been there to the various fields. Now we'll see what is engineering drawing. Say, what do you mean by engineering drawing means? A drawing which can be done to a specific dimensions by using a drawing instrument. Say, there will be dimensions to determine what is its size, shape by means of its dimensions. So dimensions means you can say that it can be a length, it can be a diameter, it can be different types of dimensions. Okay. So if a drawing is done on specific dimensions using drawing instruments such as pencil, scale, drawing board, etc. So from engineering drawing, we are able to draw any part or any component with respect to the specific dimensions. So from the engineering drawing, if say we have drawn any object or any component, say we will be able to get to know what is its width, what is its dimensions, everything we get to know. So how much it is, thickness, how much it is, width, say all the specifications. So with respect to the specifications, we are going to draw in an engineering drawing. Okay, in an engineering drawing. So now we come to know that so major difference between drawing and engineering drawing. So drawing just is nothing but a freehand sketch without using any drawing instruments. That is nothing but a drawing. But in case of engineering drawing, it is nothing but a drawing to the specific dimensions using a drawing instrument such as pencil, scales, drawing board, compass, protractor, everything which are necessary to draw to the up to the mark. Okay. Now we see in the engineering graphics, we are using a engineering drawing. So how a engineering drawing will be done in engineering graphics. So for that we are going to using a principle that is nothing but a projection principle. We all know what is projection is. It is nothing but projecting the views or images on an object with respect to the screen. We all know that. So in order to do a projection principle, we require three things. One is observer, second one is object, and third one is plane. So what we do in this projection principle? So there will be an screen, or plane, you can say that, and there will be an object, and there will be an observer, you can say that. Okay, an observer is looking the object, and the waves are falling on the plane as a image here. So we calling this as projections or projector lines. Okay, these are object and this is our V. This is what our projection principle. Okay, using the projection principle we are going to draw the engineering drawing here. We are going to draw it using this projection principle. For that, three things are necessary. One is observer, object and plane. We know that the projector lines are forming and they will be forming a projections. Okay, so now we will see a particular concept, that is orthographic projection. Because majority of the problems, say points, lines, planes and solids, up to the solids, we are using the orthographic projection. Now we will see what is orthographic projection. What is orthographic projection? Say, we know that in order to do the projection we require three things. One is plane, second one is object, and third one is observer. So three things we require for a projection. Okay, and there will be plane. We know that the projector lines or rays are falling on a plane to form a image. Okay, if these projector lines are remain parallel and will become perpendicular to this plane. Okay, plane, we calling that as an orthographic projection. So we define orthographic projection: if the rays of light are projector lines from the object remains parallel to each other and perpendicular to the plane is called orthographic projection. Or in another way we can define what is orthographic projection means. In another we can define. So it is nothing but conversion of 3D object into 2D views. You can see that this is an object, right? 3D object, and it is forming in 2D views. Okay, that is nothing but a orthographic projection. Okay, wherein we are converting a 3D object into 2D waves. Here in this we are getting a front view, similarly we can get the top view, and similarly we can get the side views. Okay, so conversion of 3D object into 2D waves is nothing but a orthographic projection. And another important thing here in this orthographic projection, the dimensions of the image having same dimensions of the image having similarity, you can say that similarity with the original object. That means we can say that there is no enlargement or diminishing in the dimensions of the images of an object. Say if the dimensions of the object are same and images of an object dimensions also same, say dimensions of the image, if it resembles similar to the dimension of an object, we calling that as an orthographic projection. In orthographic projection we get similar, that is there is no changes in the dimensions of an object occurs. Okay, there is no changes in the dimensions of an image occurs, we calling that as an orthographic projection. Now we understood, right? Orthographic projection means the rays of light or the projector lines are coming, if they remain parallel to each other and become perpendicular to this plane of projection. Okay, perpendicular, you can say that if they become perpendicular exactly 90 degree to the plane of projection, we calling that as an orthographic projection. Okay, wherein what happens, the dimensions of an image of an object remain same as that of an object. So we can define in another way is nothing but conversion of 3D object into 2D waves. So wherein the dimension of the image will be similar to that of the original object. Today we are going to learn about quadrant system in engineering graphics. So today we are going to define the quadrants by using the profile planes. So herein there is a vertical plane, there is an horizontal plane, okay, you can see that both vertical plane and horizontal plane, and it is folded or comprised of the profile plane. Okay, it's like an plus mark. Now we can define, so this is profile plane. So now we will define the quadrants. So there will be an observer. So here position of the observer, it will be fixed irrespective of the position of the object. Now we are going to define the quadrants by means of position in the object. This is our object. So now we can define first quadrant. So object is lying above the HP and in front of VP. So that is our first quadrant. Now we are going to place the object in the second quadrant. Position of the observer will be fixed. So the observer is looking object below the behind of VP and above of HP. That is our second quadrant. You can see that position of the observer has to be fixed here. Now we are keeping the object here. Now the observer is seeing the object below of HP and behind of VP. That is our third quadrant. Now similarly VP is placing here. Now the observer is looking the object here in front of VP and below of HP. Below of HP. This is our fourth quadrant. So now you can see that it will be, if it is like looking in a front view, it will look like as a plus mark. So which is consists of vertical plane and horizontal plane. Now position of the object we can define with terms of first quadrant. That is our first quadrant, second quadrant, third quadrant, fourth quadrant, okay. Now individually we can take each of these quadrants. Now initially I will take the first quadrant. Okay, it will be written like a L. Okay, first quadrant. vertical plane, horizontal plane. Now position of the object. So object is lying above the HP and in front of VP. Okay, now we can write. So this is what the definition of first quadrant in orthographic projection. Orthographic projection, first quadrant, it is nothing but in front of VP and above of HP. In front of VP and above of HP. That is our first quadrant. Similarly, we can write for the second quadrant. VP, HP. So position of the object, it is behind of VP and above of HP. Okay, second quadrant, it is nothing but behind of VP and above of HP. Above of HP. Simultaneously, we can write for the third and fourth quadrant. Third quadrant, it is nothing but behind of below of HP and below of and behind of VP. Below of HP and behind of VP is the third quadrant. Similarly, for the fourth quadrant, it is below of HP and in front of VP. In front of VP. Okay, this is all the definition of the quadrants. Now we are going to represent these quadrants in terms of orthographic projection. Okay, in orthographic projection, we are going to write in terms of on a paper, on a A4 sheet. Okay, so how these quadrants can be represented by means of an orthographic projection, we will see. We take first quadrant. Okay, here we follow one concept, that is by fixing the vertical plane. Okay, and here we are going to rotate the horizontal plane by 90 degree in clockwise direction. Clockwise direction we are going to rotate. So there is an reference line will be there. So that reference line will be there and it is connecting all the reference planes. Okay, you can see in the first diagram also. So the reference line will be there. So the reference line will be connecting all the reference planes. Okay, that is our reference line. So as we have rotated the HP plane, what is happening in the next step is the HP will come down of the reference line. Okay, and in the final step it will become like this. When we write XY line, VP will be above the XY line and HP will be below the XY line. This is how we represent them in quadrant, in orthographic projection. Simultaneously, we can write for the second quadrant. You can see here. So we are going to fix the vertical plane and rotate horizontal plane by 90 degree in clockwise direction. Okay, and it is the same procedure wherein VP will be fixed. So in this step, what happens, both vertical plane and horizontal plane will be above the XY line. Okay, both horizontal plane and vertical plane will be above the XY line. Now in third quadrant also we follow the same step. We take part of the quadrant, that is third quadrant. It will be like this. This is HP, this is VP. So we are going to fix the vertical plane and we rotate the horizontal plane by 90 degree in clockwise direction. Same procedure. So here HP will be coming above the XY line and VP will be below the XY line. So finally we can write HP will be above the XY line and VP will be below the XY line. Now finally we can write for the third quadrant. So in the fourth quadrant, same procedure, fixing the vertical plane and rotating HP by 90 degree in clockwise direction. So there will be a reference line. So what happens in the next step, it is both VP and HP will be below the XY line. So finally we get it like this, that is both VP will be below the XY line. So finally we can write, so quadrants will be represented by means of orthographic projection like this. First quadrant, that is VP above the XY line and HP below the XY line. Second quadrant, both HP and VP will be above the XY line, and in third quadrant HP will be above the XY line and VP will be below the XY line. And in the fourth quadrant, so it is the reverse of the second quadrant, that is both HP and VP were below the XY line. So we can make vice versa. First quadrant, it is the vice versa of the third, and second is the vice versa of the fourth quadrant.